let's say we had m equals -4 and a point 2, -3. And we wanted to find the equation of the line with this slope through this point. And we wanted it in the form y equals mx plus b. We wanted it in slope-intercept form. What we would have to do is see what variables we have and then use that information to solve for what we don't have. So here we have the point 2, -3. This is an x, y. We have m, so we have y, we have m, we have x. We can use these things to solve for b. So when y is -3, m is -4 times x, that's +2 plus b. And we are solving for b. We can simplify here. -4 times +2 would be -8 plus b. So to get b by itself, we have to undo subtracting 8. We add 8 to both sides. -3 plus 8 is +5. We get +5 equals b. Well, now we have this extra information, b equals 5. And when we have m and we have b, we can fill in y equals mx plus b, but instead of the solving for b version, we're going to leave y and we're going to leave x as y and x, just like we would see it in the equation itself. So our m was -4. Our b plus b is +5. So unless the point they're giving us is literally 0, 5, unless it's the y-intercept, we can't look at a slope and a point and plug things directly in. Now, if instead of 2, -3, the point we were given was 0, 5, this becomes a lot easier because 0, 5 is the definition of the y-intercept, and the y-intercept is b. So we can go -4 is x, 5 is b. But without being given that y-intercept, we have to use m, x, and y to solve for b first. And then once we have that b, we can get the equation in slope-intercept form. How about if we wanted to pass through the point -1, -4 and have a slope of 3? Well, if they tell us we want our answer in slope-intercept form, that's y equals mx plus b form. We have an x and a y we could use along with our m, our slope. -4 equals 3 times -1 plus b. 3 times -1 is -3. plus b. Add 3 to both sides. B equals -4 plus 3, -1. So now that I know b is -1, y equals mx plus b would be, leave y and x alone now. Y equals 3x plus -1. In other words, y equals 3x minus 1. But probably massacring the words of Yoda, there is another. In this case, it's not yet another Skywalker. It is yet another form of a linear equation. So what do I mean by that? I don't want to lose this information from our mind. So let me write what we've found so far. Y equals 3x minus 1. And we wanted our answer in slope-intercept form. But there is another way. Just because the final answer is in slope-intercept form doesn't mean that it's the only way to start the problem. But to go through what we know, I cannot drive it home enough. Slope-intercept form is y equals mx plus b. We also had our general form, ax plus by equals c. We're going to do more with this one. Now we're going to have a form called point slope form. And this comes, believe it or not, from the slope formula, which means it really comes from the coordinate plane, the Pythagorean theorem, the distance formula. But as our starting point, let's imagine the slope formula, y2 minus y1 over x2 minus x1. Well, instead of having 2 points, we're only going to have 1 point. So imagine now that our x2 and our y2, they're just y and x. Because our second point is just going to be any xy. If I multiply both sides, let me switch the order, because remember, an equality is an equality. Okay, so I've swapped the sides so that my equals m is on this side. If I multiply both sides by x minus x1, that makes the fraction go away and puts it here. Y minus y1 equals m times x minus x1. And you know, as weird as that is, that's the form. Why is it a form? Well, because it's just the slope formula in a different, I don't want to say form again. It's just the slope formula in a different costume, but it's still the slope formula. And since the slope formula is always true, this is always true. So it's a line form. X1 and Y1 would be the point in point slope. And of course, M would be the slope in point slope. When we did this problem and started with y equals mx plus b, we replaced our x and our y to solve for b, and then ended up having to write y equals mx plus b again and plug in our m and our b. If we start with point slope form, y minus y1 equals m times x minus x1, we don't have to worry about solving for something and then plugging it back in later. If we start by writing point slope form and we keep simplifying line by line, eventually we are going to get all three forms written right out without any substitution. We're going to hit point slope form almost immediately. Then we're going to hit slope intercept form, y equals mx plus b. And then we can keep going from there and we can get it into ax plus by equals c form. So we'll use this problem as our path. And we already know in slope intercept form, we should expect to get y equals 3x minus 1. So instead of making our point x, y, if we're going to start point slope form, we need to realize that's x1, y1. X and y are just going to stay x and y through all of the different forms, wherever we're going to jump off, whichever one the answer requires us to be in. Y minus what? What is y1? Negative 4. Y minus negative 4. Equals. What's our m? Our m is 3 times what? X minus what's x1? Negative 1. So I'm seeing that my hand is frozen. I'm just waiting for that to catch up. Okay. Looks like the bad internet is trying to ruin our night. The only update, we need to finish this off to get point slope form. When we see minus and negative, we know we change that to plus. Y plus 4 equals 3 times x plus 1 minus negative 1 becomes plus 1. So that would be the point slope form here. But let's say the problem said, hey, put it in slope intercept, put it in y equals mx plus b. Well, from here, that means we would solve for y. How do we solve for y? Distribute to get rid of the parentheses and then get the y by itself. Combine like terms. So if I distribute the 3, y plus 4 is 3x plus 3. And then if I subtract 4 from both sides, we're left with y on the left. Plus 3 minus 4 is negative 1. 3x minus 1 on the right. So that would be slope intercept form. We can get there through point slope form. I said we'd get all three forms. So y equals 3x minus 1. If I subtract 3x from both sides, I get negative 3x plus y equals negative 1. This is only one of the two ways to do ax plus by equals c form. The other is to change the sign on every term. So instead of negative 3x, it'd be plus 3x. Instead of plus y, it would be minus y. And then instead of minus 1, it would be plus 1. If there is a convention, that convention is the x's need to be positive. So even though these are interchangeable, and sometimes you will see it this way, let's say you're doing this and it's a multiple choice test. You do all your work and you get this, but this isn't an answer. Well, change all the signs. If you did it right, this one will be the answer. It'll be there. So while there is some discrepancy and this one's preferred, there will never be one that has a fraction in your final answer. You can and likely will have fractions in point-slope form and in slope-intercept form. But you cannot have fractions in ax plus by equals c form, in general form. Let's do more work with point slope. Okay, this time we want to go through the point 2, -3 with a slope of -4. And we want our final answer in ax plus by equals c form, in general form, standard form. The one that is not point slope or slope intercept. Well, to do this problem, I'm going to start out with point slope form. I'm going to write y minus y1 equals m times x minus x1. I'm going to plug in what I know, and what I know is I have an x1, y1, and I have an m. Y minus y1 is -3 equals m is -4 times x minus x1 is 2. This is y plus 3 equals -4 times x minus 2. So if it wanted point slope form, that would be my point slope answer. It doesn't. It wants ax plus by equals c. So we push through and we bring it into slope intercept form. We're going to go ahead and we are going to solve for y. So distribute the -4. -4 times x is -4x. -4 times -2 is +8. And if I subtract 3 from both sides, I get y equals -4x plus 5. And if it wanted slope intercept form, if it wanted y equals mx plus b form, that would be it. But it doesn't. It wants ax plus by equals c. And that just means we got to get our x's and y's on the same side. So this minus 4x, if I add that over to the left, if I add it to both sides, which in effect adds it to the left and gets rid of it on the right, then that would be positive 4x plus y equals 5. Or if you ended up somehow with things switched around, you could have a minus 5 on that side and a minus y over here. So negative 5 equals negative 4x minus 5. Negative 5 equals negative 4x minus y. So, or just switch all the signs, minus 4x minus y minus 5. But convention says we want to use the one that has the positive number of x's. Let's do it again. Same thing, ax plus by equals c as our final form. We're going to start with point slope though. This time we are told the point we're going to go through is negative 5, 2. The slope we're going to use is negative 3. So that's our x1, y1. Y minus y1 is y minus 2. Equals m is negative 3. X minus negative 5. So this is y minus 2 equals negative 3 times x plus 5. That's our point slope form. If that was our jumping off point, we'd be done now. But it's not. We want to take it all the way, so we go through. We're going to go through slope intercept now. Y minus 2 equals negative 3x minus 15. I distributed the negative 3. If I add 2 to both sides, y equals negative 3x, negative 15 plus 2 is negative 13. And if I add my 3x over to the other side, I get out of slope-intercept form, out of y equals mx plus b form, to here. Moving the 3x over, we'd have positive 3x plus y equals negative 13. Our next one, we're going to go ahead and give our answer in slope-intercept form. There are going to be multiple ways to arrive at the final answer here. Now I'm not going to give you the slope. I am going to give you 2 points. For negative 6 and negative 1, 2. Normally, up until now, frozen hands, wonderful. Up until now, if I gave you a problem with 2 points, then the thing we would probably be doing is finding the slope. Instead, we are finding the equation of the line. Find the equation of the line. Through 4, -6, and -1, 2. In slope intercept form. So remember, I just said when we get 2 points, normally we want to find the slope. And since they don't give us the slope, that's exactly what we have to do. Before we do anything, our first step is going to be, hey, find M, find the slope. So the slope formula, y2 minus y1 over x2 minus x1. I just made this x1, y1. I made this x2, y2. 2 plus 6 over -1 minus 4. 2 plus 6 is 8. -1 minus 4 is -5. That means I have a slope of -8/5. So here, once we found our magic information that M equals -8/5, we have so many options. I'm going to show many of them. You don't need to do all of them. You only need one of them. You need to get the slope-intercept form of the line through these 2 points any way you can, short of cheating. But at this point, you're having fun. You wouldn't even think about it. So at the beginning of our time together today, before we knew what point slope form was, I showed you if we need to finish in y equals mx plus b, we can start there. We can use what we know to solve for b. And I said we can pick an x and a y. Here, there's an x and a y. There's an x and a y. How do I know which one to pick? Well, this is one of those cases where it doesn't matter which one you pick. You're going to get the same answer either way. So let's say I pick this first one. Then y would be -6. M is -8/5. X, still in the first one, so that's 4. Plus b. Ew. Well, let's work with this fraction. -8/5 times 4. That's like times 4 over 1. That's going to be -32 over 5 plus b. In order to solve for b, we're going to have to do some adding and subtracting of fractions. Since the denominator here, the bottom number is 5, we would like to write -6 as a fraction over 5. Negative 30 over 5 is how I'm rewriting negative 6, and then the rest is just the right side. To get the b by itself, I need to get rid of subtracting 32 fifths. So I'm going to add 32 fifths to both sides. So adding it on the right just leaves me with b. Adding it on the left, negative 30 plus 2, sorry, negative 30 plus 32 leaves me with positive 2 fifths as my b. Negative 30 plus 32 is positive 2 fifths. 2 fifths is b. And once I have an m and a b, y equals mx plus b. And that's the answer. Y equals negative 8 fifths x plus 2 fifths. I'm going to show this at least 3 more ways. That's one of them. That was picking this point and starting with slope-intercept form. I'm going to do it again, but I'm going to pick the second point. I'm going to show you we get the same answer. So using the second point, y is 2. M is that annoying negative 8 fifths. X is negative 1 plus b. This one's a little bit easier, at least over here, because something times negative 1 is just the opposite. So 2 equals positive 8 fifths plus b. Since I'm going to have to subtract 8 fifths, I'm going to rewrite 2 as 10 fifths equals 8 fifths plus b. So 10 fifths minus 8 fifths, subtracting 8 fifths from both sides just leaves me with b. And 10 fifths minus 8 fifths gives me a b, once again, of 2 fifths. Y equals mx plus b. So using the second point gives me the same thing. Or we can do them all the same way. We have this process now that starts with point slope form and lets us have off ramps. Let's look at that. Y minus y1 equals m times x minus x1. So this is way 3. Still would start by using the slope formula to find the slope. But if I go ahead and use this first point as x1, y1, y minus negative 6 equals negative 8 fifths times x minus x1, using the first point still. So x minus 4. Minus a negative here turns this into y plus 6. And here's where things start to get tricky. To turn this point slope form into the slope intercept form that we need, we would first need to distribute this fraction. Y plus 6 equals negative 8 fifths x plus 32 fifths. Isn't this fun? Let's turn our 6 into fifths, and we're going to subtract 6. Subtracting 6 would be subtracting 30 fifths, and then negative 32 fifths minus 30 fifths gives us the 2 fifths. So we do get our slope-intercept form that way as well. I said 4 ways. Here is way 4. I'm going to go ahead and use this second point as my x1, y1 in point slope form, bringing it all the way to slope-intercept. And yet again, we will get the same answer. You don't need to be able to do it 4 ways in one sitting or 4 ways at all. You just need one. And I'm just showing you with this example that any of the 4 ways works. Y minus, using the second point, y1 is 2, equals m is still that annoying negative 8 fifths. X minus x1, negative 1. So that's a y minus 2 equals negative 8 fifths times x plus 1. If we distribute the negative 8 fifths, that's y minus 2 equals negative 8 fifths x minus 8 fifths. I'm going to add 2 over, but adding 2 is the same as adding 10 fifths, and negative 8 plus 10 is positive 2 fifths. So there we go again. Any way you have to get to slope-intercept form is good, as long as you give me your answer in slope-intercept form if it is asked in slope-intercept form. But you don't have to start there. You can start with point slope. Or you can start with slope-intercept and do the solving for B. You've seen it all works. I'm going to do one last thing with this answer before we move on. I'm going to bring it to ax plus by equals c form, just in case that is what was asked for here. I had said it's not enough to bring it over. It's not enough to have 8 fifths x plus y equals 2 fifths. And it's because there is fractions here. How can we get rid of fractions with a 5 on the bottom? We can multiply both sides by 5. That'll leave us with 8x plus 5y equals 2. And that would be ax plus by equals c form. Why? Because 5 times 8 fifths is 8. The 5's cancel, so 8x. And then we're distributing, so 5 times y is 5y. And then we end up with 5 times 2 fifths, and again, the 5's cancel and just leave 2. But ax plus by equals c form cannot have any fractions in the final answer. So honestly, even before moving things around, it might be easier to get rid of the fractions here. Because here we'd be multiplying by 5 to get rid of the 5s, and here we're multiplying by 5 and it sticks. Negative 8x plus 2 added over 8x plus 5y equals 2. The slope of a line is the change in y over the change in x, or the rise over the run. Rise is your vertical change, run is your horizontal change. Rise can be calculated with y2 minus y1, and run can be calculated with x2 minus x1. What are these x1, x2, y1, y2? Well, they are distinct points, x1, y1, and x2, y2, that we're looking at the line through. And x2 minus x1 can't be 0 because we cannot divide by 0. That's never going to change. So we can see graphically, if we had the points x1, y1 and the point x2, y2, the slope would be how much we go up over how much we go right. The rise over the run. And the distance between y1 and y2 would be y2 minus y1. The distance between x1 and x2 would be x2 minus x1. Always remember that it's the x's on the bottom. If you imagine that the x's and the y's above and below the bar form a picnic table with something on it, having the x's on the bottom provides the sturdiness for the picnic table to not fall over. Y's on the bottom would just fall over. So let's use the definition of slope, the slope formula, to find the slope of the line passing through the points 4, -2 and -1, 5. So we write down our slope formula, m, the letter we use for slope, equals y2 minus y1 over x2 minus x1. Be careful when you plug in your values, because some of them are negative. And since we're subtracting, specifically on the top, subtracting y1, we want to be sure that we are subtracting the entire -2. And minus a -2 becomes a +2. 5 plus 2 is 7. -1 minus 4 is 5. That's 7 over -5. Positive divided by negative is negative, so -7/5 is the slope of the line that passes through these 2 points. Next, we'll talk about the point slope form of the equation of a line. And the point slope form is y minus y1 equals m times the quantity x minus x1, where the slope is m and a point that the line passes through is x1, y1. So let's write an equation in point slope form for the line with slope 6 that passes through the point 2, -5. Then we're going to solve that equation for y. So we start by writing out point slope form. Y minus y1 equals m times x minus x1. And then we plug in what we can. We know that m, the slope, is 6. We know that x1 is positive 2. We know that y1 is negative 5. And we're careful that we put that negative 5 in parentheses so that we are aware that we have y minus negative 5 equals 6 times x minus 2. Y minus negative 5 is y plus 5. So this is the equation in point slope form. We were told to go on and solve the equation for y. So in order to do that, we get rid of the parentheses first, distribute the 6. Y plus 5 equals 6x minus 12. And then subtract 5 from both sides. Y equals 6x minus 17. This is a special form of a line. It's in the form y equals mx plus b. So y on one side solved for y. On the other side, one term is our slope multiplied by our x. And the other term is a constant. We call this slope-intercept form. Y equals mx plus b. M is still the slope, but we have this constant b, which is the y-intercept. When we have something in slope-intercept form, when we have something in y equals mx plus b form, we could use that to graph the line. Specifically, it gives us the point 0b. It gives us the y-intercept. So plot that point first. And then from what we know about the slope, make sure it's written as a fraction. If not, put it over 1. And then use rise over run. The top number is your rise, how much you go up or down. The bottom number is your run, how much you go left or right. Positive is up or right. Negative is down or left. So count over using the slope from the y-intercept point. That gives you 2 points, which is enough to draw a line. So use a straight edge to draw a line through the 2 points. And draw arrowheads at the ends of the line to show that the line continues indefinitely in both directions. All lines have arrows on both ends. So here we have something in y equals mx plus b form, 3/5 x plus 1. It says f of x equals, but we know that f of x is y, so that's okay. The plus 1 tells us that we have a y-intercept of 1. So we plot the point 0, 1. Oop. And now 3/5 3/5 counting off from our y-intercept is going to be up 3, 1, 2, 3, right 5. And we'll place our second point there. It would be at 5, 4. Again, we didn't count from the origin, we counted from the y-intercept. So up 3 took us to 4, and then right 5 takes us to 5, 4. Then connect the dots with a line that goes through the dots. And we have arrowheads on both sides to show that the line continues in both directions. One interesting thing about the slope of 3/5 is that 3/5 is not just plus 3 over plus 5. It's also minus 3 over minus 5. Negative over negative is positive. So we could have gone down 3 and left 5 and come up with another point on that same line. So how you interpret the signs of the fraction is up to you. You will get a point whether you go up and right or down and left. Or in the case of a negative number, whether you go down and right or up and left. Negative over positive is negative, but so is positive over negative. A horizontal line has a special form, y equals b, where there is no x in the equation at all. The only thing that we need to make a horizontal line is a specified y-intercept. It doesn't matter what x is, because if x is 1, y is b. If x is 4, y is b. If x is 8, y is b. Let's take a look at y equals 3. If we made a table, it doesn't matter what x is, y is always 3. So we can say x is -2. That means y is 3. We could say x is 0. That means y is 3. We could say x is 2. That means y is 3. We end up with this horizontal line where y is 3. So I always like to tell people that the y equals number, the graph of that line, since it has a y, it crosses the y axis. So y equals a number will strike the y-axis. That means those are horizontal lines. On the other hand, a vertical line is a line given by x equals a, where it doesn't matter what y is. There is no y. X equals is going to cross the x-axis. It's going to have an x-intercept. And since these lines are straight up and down, the x's are always the same. The slope is undefined. We tried to plug 2 points from this line in on the slope formula, we would end up dividing by 0. That's why we say the slope is undefined. The general form of the equation of a line has the x and the y on the same side of the line. Now, sometimes you might see this as ax plus by equals c with the constant on the other side. Sometimes you'll see it as ax plus by plus c equals 0 with everything on one side and 0 on the other. The important thing about general form is that the x and the y are on the same side. There's no common agreement as to where the constant ends up. This particular book that we're using puts everything on one side and 0 on the other. Let's find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 equals 0. Well, slope and intercept, we can get those from slope-intercept form, y equals mx plus b. So we'll take what we have, our equation, and start solving it for y. Subtract the 3x and add the 12. We have 6y equals -3x plus 12. Divide both sides by 6. That divides everything by 6. So y equals -1/2 x plus 2. From here, we can see that the slope is -1/2 and that the y-intercept is 2. M is -1/2, B is +2. So we were given something in general form, and to answer questions about it, we had to change it to slope-intercept form. That doesn't make the general form seem very useful. So what is it good for? Well, it's very good for using intercepts to graph. Recall that for x-intercepts, y is 0, and for y-intercepts, x is 0. So we plug 0 in for the other variable and solve for our intercept. Plot the x and y intercepts, and that gives us 2 points to draw a line through. So as long as none of A, B, and C is 0, the graph will have distinct x and y intercepts, and this 3-step method can be used to graph the equation. Now, if it turns out that the x-intercept and the y-intercept is the origin, we would need to plug in some other values to find a second point. But most of the time, this is going to work out for us. 3x minus 2y minus 6 equals 0. To find the x-intercept, we let y be 0. That's going to make that middle term disappear completely. So instead of minus 2y, it'd be minus 2 times 0, which just leaves us with 3x minus 6 equals 0. 3x equals 6, x equals 2. So we've found the x-intercept. When y was 0, x was 2. So that's 1 point. For our other point to make our graph, we'll find the y-intercept. This time we'll let x equals 0 and solve for y. Letting x be 0 makes that entire first term disappear. We just have minus 2y minus 6 equals 0. Minus 2y equals positive 6. Y equals negative 3. So again, the steps for solving: plug in 0 for the other variable. That makes that term disappear completely. Here, that left us with negative 2y minus 6 equals 0. We add 6 to both sides, and then we divide both sides by negative 2. We get y equals negative 3, so that means that we have our y-intercept now. Plot the x-intercept, plot the y-intercept, draw the line through. So an application problem could be: use the data points 317, 57.04 and 354, 57.64 to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million. Round m to 3 decimal places and b to 1 decimal place. We're given 2 points. We can find the equation of a line or of a function that contains those 2 points. The first thing we'll need is the slope. So slope formula to the rescue. 57.04 subtracted from 57.64, then 317 subtracted from 354. That gives us 0.60 divided by 37. And that gives me 0.016216216, probably a 2 after that. We want to round it to 3 decimal places by the instructions. So the 2 does not round the 6 up. 0.016 is our approximation to 3 decimal places for m. Y minus y1 equals m times x minus x1. That's a good starting point when we need an equation of a line. Plug in our m, plug in our x1 and our y1. It doesn't matter which of the 2 points you use. You'll get the same final answer in slope-intercept form. But we want to get rid of the parentheses. We'll distribute that 0.016. And then we'll add the 57.64. And we get y equals 0.016x plus 51.976. But recall, the intercept b was to be rounded to 1 decimal place. So 0.97, that's going to round the 9 up to 0.0, carry the 1, 52.0. So the function we've created, f of x, models global temperature, average global temperature, for an atmospheric carbon dioxide concentration of x parts per million. And that's it for this topic. The objectives in this topic are find slopes and equations of parallel and perpendicular lines, interpret slope as rate of change, and find a function's average rate of change. Let's talk about parallel versus perpendicular. Specifically, parallel versus perpendicular slopes. Now, parallel lines would be like this. 2 lines that, if they go off in both directions forever, would never touch. So they're not set up to intersect on any sort of angle at all. They will never intersect. And the reason they wouldn't intersect has to do with their slopes. The slopes for 2 parallel lines are the same. If this was a slope of let me put it over here. See, up and over the same distance. They have the same slope. And because they have the same slope, it keeps them on the same path. And they won't cross. Perpendicular lines not only do they intersect at a right angle. Perpendicular lines have opposite reciprocal slopes. Now that is a mouthful. What does that mean? Opposite, positive, negative. Reciprocal, flipping a fraction. So if I had a slope of, I don't know, 2/3, a parallel slope would also be 2/3. But a perpendicular slope, and I'll use this as the symbol for perpendicular, the symbol for perpendicular. The perpendicular slope would be -3/2. Negative because it's the opposite, 3/2 because it's the reciprocal. And I'll use that as the symbol for parallel, just two little parallel lines. Parallel lines have the exact same slope. So same for parallel, opposite reciprocal for perpendicular. Let's find the line through the point -4, 1 parallel to the line defined by x plus 4y equals 3. And let's do both slope intercept form and standard form. Standard form's ax plus by equals c form. So when we see a problem about parallel or perpendicular, all that means is we got to have a same slope for parallel. We have to have opposite reciprocal slope for perpendicular. We don't see any slope information here, but we know it has to be parallel to this. So let's find the slope of this first. The easiest way to see slope is to solve for y. So x plus 4y equals 3. Let's solve it for y. I'm going to subtract x. So 4y equals -x plus 3. And then dividing everything by 4 means y equals -x over 4 plus 3 over 4. Knock that x off to the side, remember. And that's like we have an invisible 1 up top, -1/4 x plus 3/4. That's a line and slope intercept form. Is that half of our answer? No. We haven't done anything with the problem yet except take this x plus 4y equals 3 and put it in slope intercept form. We did that so we can see what m is. Y equals mx plus b. M is -1/4. A line parallel to something with a slope of -1/4 will also have a slope of -1/4. So now we could actually do our work. we have our slope, which is also going to be negative 1/4, and we have a point, negative 4, 1. All we pulled from all of that solving for y, that's just the slope. That's all we needed. I'm going to start with y minus y1 equals m times x minus x1, point slope form. Here's our x1, here's our y1. Or you could use one of the other methods to get slope intercept. I'm going to use this one. Y minus 1 equals m is negative 1/4 times x minus x1, x minus negative 4 is x plus 4. I'm not going to waste a line just writing a minus a negative. We know minus a negative is going to become plus. So let's do it. I'm going to distribute this negative 1/4. Y minus 1 equals negative 1/4 x. And then negative times positive is negative. 1/4 times 4. 1/4 times 4. 4's cancel. It's just 1. Doesn't just magically all go away. Negative 1/4 times positive 4 is negative 1. And then I'm going to go ahead and add the 1 to both sides to solve for y. And I get y equals negative 1/4 x. No constant term. So y equals negative 1/4 x. That's actually our slope-intercept form. That's half that answer. Then we need to get it into general form. Let's get rid of the fractions first. How can I get rid of the fraction with a 4 on the bottom? I can multiply both sides by 4. That's going to give me 4y equals 1/4 and 4 cancel each other out. So just minus x. If I add x over to this side, x plus 4y equals 0. That would be our general form. Over here, I went off a little bit, but that was part of times 4 on both sides. What would have changed had the problem said perpendicular to this line? Well, then instead of using a parallel slope of negative 1/4, we would use an opposite reciprocal slope. The opposite reciprocal slope would have been a positive and then 4/1, positive 4. But that wasn't the problem. Let's do a perpendicular one, though. If you need a break, take a break.